Have you ever wished for a little more time in your day? Maybe you found yourself glancing at the clock, hoping for just a few extra minutes to finish a task, or to savor a peaceful moment before the rush begins. Time feels so fixed, so absolute. Yet what if I told you that the very length of our day is quietly shifting beneath our feet? Well, the length of our day is actually changing all the time. It's not just a trick of the mind or a feeling we get when we're busy. Our planet's rotation is in constant subtle flux. Our planet, Earth, is like a giant spinning top in space, turning steadily to give us the rhythm of day and night. But unlike a perfectly balanced toy, Earth's spin is influenced by countless forces, both inside and out. But scientists have discovered something amazing. Earth's rotation isn't as constant as we once believed. With precise instruments and decades of observation, they've found that our planet's spin can subtly shift, sometimes in ways we never expected. It can speed up and it can slow down, though only by a few milliseconds at a time. These changes are so tiny that we don't notice them in our daily lives, but they're happening all the same, ticking away in the background. You'd never notice it, but these tiny shifts are a big deal to scientists. Even a fraction of a second matters when you're tracking satellites, running global communications, or studying the history of our planet. By studying why our planet's spin is changing, we learn about everything from the melting of ice caps and shifting oceans, to the churning of the molten core deep beneath our feet. Each of these elements leaves its own fingerprint on the way Earth turns. Earth is a dynamic living system, not just a solid rock. Its surface and atmosphere are always in motion, shaped by winds, tides, and the energy of the sun. Even the growth of forests and the movement of water can play a role in this grand cosmic dance. Oceans, atmosphere, ice, and the core all affect how our planet spins. The push and pull of tides, the shifting of glaciers, and the swirling of air currents all add up, nudging Earth's rotation ever so slightly. It's like a figure skater changing speed by moving their arms. Earth does a similar dance on a grand scale. When mass moves closer to the center, the spin quickens. When it moves outward, things slow down. Our planet is constantly adjusting, responding to the forces within and around it. Understanding these changes helps us understand the health of our planet. By tracking the subtle shifts in Earth's rotation, scientists can detect changes in climate, sea levels, and even the balance of life on Earth. So, let's explore the surprising science behind our planet's ever-changing day. Join us as we uncover how the ticking of Earth's clock reveals the hidden stories of our world, and why even the smallest changes can have a big impact on life as we know it. Why does the Earth spin at all? It's a question that seems simple, but the answer takes us on a journey back to the very beginning of our solar system, and even to the origins of the universe itself. The story begins over 4.5 billion years ago, with a vast, swirling cloud of dust and gas drifting through the emptiness of space. This cloud, known as a solar nebula, was the birthplace of everything we know in our solar system. Gravity, the invisible force that shapes the cosmos, slowly pulled this cloud together. As it collapsed under its own weight, it began to spin faster and faster, just like a figure skater pulling in their arms, or water swirling down a drain. This spinning motion is a fundamental law of physics in action. This is called the conservation of angular momentum. Once something starts spinning, it keeps spinning, unless another force acts to stop it. It's why a spinning top keeps turning, and why the planets keep rotating long after their formation. At the center of this spinning disk, the sun ignited into life, while the leftover material flattened into a disk. From this disk, the planets, including our own Earth, slowly took shape, inheriting the spin of the original cloud. Earth's spin is a direct remnant of those ancient cosmic events. And because space is nearly empty, there's almost nothing out there to slow it down, so our planet keeps turning, day after day. This constant spin is what gives us the cycle of day and night. The speed of Earth's rotation determines how long our days are, shaping the rhythm of life for every creature on the planet. But Earth hasn't always spun at the same speed. In its early days, our planet rotated much faster. A single day lasted only a few hours. Imagine how different life would be if that were still true. Over billions of years, the gravitational pull of the moon has acted like a gentle brake, gradually slowing Earth's spin. This process, called tidal friction, continues even today, making our days just a tiny bit longer each century. Every planet in our solar system spins at its own unique speed. Some, like Jupiter, spin incredibly fast, while others, like Venus, turn so slowly that a day lasts longer than a year. But Earth's 24-hour day is just right for the life that has evolved here. Yet, our planet's spin isn't perfectly steady. Earth wobbles and tilts on its axis, a motion known as precession. These subtle changes can affect our climate and even the length of our days over long periods. Today, scientists use advanced telescopes, satellites, and precise instruments to measure these tiny wobbles and shifts. By studying them, we can learn more about our planet's past and its future. Let's find out how we measure them. How do we know the length of a day is changing by just a millisecond? We can't use a regular stopwatch. For centuries, people measured days by the sun's position, solar days. But for real precision, scientists use distant stars and quasars as reference points. This gives us the sidereal day, a more stable measure of Earth's true rotation. The technology is incredible. Networks of radio telescopes around the world use very long baseline interferometry, or VLBI. By comparing signals from distant quasars, scientists can measure Earth's rotation down to microseconds. Atomic clocks, which measure the vibrations of atoms, provide an even steadier reference. By comparing atomic time to Earth's rotation, we see the tiny differences. If Earth slows down, the astronomical day gets longer compared to atomic time. This is how we know our days are changing, sometimes getting longer, sometimes shorter. These measurements reveal the hidden forces shaping our planet. One surprising reason Earth's spin changes is melting ice at the poles. Think of Earth as a spinning figure skater. When ice melts and water moves from the poles to the equator, it's like the skater stretching their arms out. This redistribution of mass makes Earth a bit wider and slows its spin. Global warming is causing polar ice to melt rapidly, and the meltwater spreads across the globe. The result? Earth's rotation slows, making our days slightly longer. But recently, scientists noticed Earth is actually speeding up, some of the shortest days ever recorded. Other forces are overpowering the slowing effect of melting ice. It's a complex system, with many factors pushing and pulling on Earth's spin. The story of our day's length is a tug-of-war between ice, oceans, and deep Earth forces. Understanding these changes shows how human activity can affect the entire planet, and the mystery is still unfolding. When we think about what shapes our planet, we often focus on the surface, mountains rising, continents drifting, oceans shifting. But beneath our feet, far deeper than we can ever dig, even bigger and more mysterious forces are at work, quietly shaping the world in ways we're only beginning to understand. Deep below the crust and mantle lies the Earth's core, a scorching, restless sphere of molten metal, mostly iron and nickel, swirling and churning with unimaginable energy. Temperatures here soar higher than the surface of the sun, and the pressure is crushing. The outer core is liquid, moving independently from the solid mantle above it. Imagine spinning a raw egg. The liquid center sloshes and swirls inside the shell, moving on its own. That's what's happening deep inside our planet, on a massive scale. This restless movement of molten metal generates Earth's powerful magnetic field, which shields us from harmful solar radiation. It also transfers energy to the mantle, subtly nudging the planet's rotation and even influencing the length of our days. Scientists have discovered that unpredictable, short-term changes in the flow of the core can actually cause tiny, irregular shifts in how long a day lasts, sometimes making days just a fraction of a second longer or shorter. In recent years, Earth's rotation has even sped up slightly, and many experts think this could be linked to changes in the core's swirling currents, though the exact reasons remain a puzzle. Studying the core is incredibly challenging. We can't drill anywhere near that deep, so scientists rely on indirect clues, like the way seismic waves from earthquakes travel through the planet, or how the magnetic field shifts over time. Ultra-precise atomic clocks and advanced instruments allow researchers to measure the Earth's rotation down to the tiniest fraction of a second, helping them decode the hidden rhythms of our planet's interior. The subtle wobbles and shifts in Earth's spin are like secret messages from the core, offering hints about the dynamic processes happening far below the surface. All of this reveals a world in constant, restless motion, where even the length of a day is shaped by the invisible dance of molten metal deep inside. The core's ever-changing dance is a vital part of Earth's ongoing story, influencing everything from our magnetic shield to the very rhythm of time itself. And as scientists continue to study and model these hidden depths, the core keeps surprising us, reminding us that our planet is alive, dynamic, and full of secrets yet to be uncovered. Beyond Earth's surface and core, the Moon is a major player in our planet's rotation. The moon's gravity pulls on Earth's oceans, creating tides and friction. As Earth spins under these tidal bulges, the friction acts like a brake, slowly lengthening our days. This tidal braking is why Earth's days have grown from just a few hours to 24 over billions of years. But as Earth slows, energy transfers to the moon, pushing it farther away, about 3.8 centimeters per year. Over the long term, the moon is the dominant force, steadily slowing Earth's spin. Yet, on shorter timescales, other factors, like melting ice and core changes, can temporarily speed things up. That's why we sometimes see days getting shorter, even though the long-term trend is longer days. It's a cosmic tug-of-war. The moon, the ice, and the core all shaping our day. The balance is delicate and always shifting. Our planet's rhythm is set by forces both near and far. Does a millisecond really matter? For most of us, no, but for our technology, it's huge. Systems like GPS rely on ultra-precise timekeeping. Even tiny errors can throw off navigation. To keep atomic clocks in sync with Earth's rotation, scientists add leap seconds, just like leap years. Since 1972, we've added 27 leap seconds as Earth slowed down. Now, with Earth speeding up, we might need a negative leap second, removing a second, which could cause chaos for computers. Many systems aren't designed for a missing second, risking data errors and outages. Because of this, the world's timekeepers plan to stop using leap seconds by 2035. Instead, they'll let atomic time and Earth time drift, making bigger adjustments only when needed. Even the tiniest changes in Earth's spin ripple through our digital world. Tracking Earth's rotation isn't just about clocks, it's about understanding our planet's health. The speed of Earth's spin is a key measurement for scientists, revealing changes in shape, gravity, and orientation. Shifts in rotation help confirm the impact of climate change, like melting ice redistributing mass. This data is vital for climate models and predicting sea level rise. Changes in spin also give us clues about the mysterious core and our protective magnetic field. The reasons behind a longer or shorter day are tied to the biggest environmental questions of our time. Earth's spin connects ice, oceans, air, and the core into one system. By listening to our planet's rhythm, we learn how everything is connected. The story of Earth's spin is a story of our world's health and future. The story of Earth's changing rotation is really the story of our home. It reminds us that our planet is alive, dynamic, and interconnected. Human curiosity has given us the tools to measure these tiny changes and understand their meaning. Forces like the moon, melting ice, and the core all shape our days and our future. Our actions ripple through the planet, affecting even the length of a day. By understanding these processes, we become better stewards of Earth. The pulse of the planet is our pulse too. Listening to Earth's rhythm helps us understand our place in the universe.